All right, this week we're building a building system. Let's go ahead and do the demonstration first. Okay, hit play, run up. You see in the bottom left corner we have our wood, stone, and berry resources. Run up, press F. You can see it increments, so we collect 5 at a time from the trees, 1 at a time from the berries, 5 at a time from the wood or stone. Okay, come over, press C to go to the crafting. You can see those available resources right here. What is craftable in the center? You can increment and decrement the number to be crafted, and when you do so, the icon values also increment and decrement. And then after you've crafted them, it tells you how many of those crafted items you have. So let's go ahead and make 2 walls. Let's make 2 floors. We'll make 2 ceilings and 1 window. Okay, that was the pressing C for the crafting window, pressing B for the build menu. Okay, we'll go ahead and go, let's make the wall. So I do snap to grid using a 100 scale grid. Okay, we got that. Got that. I can put up uh, the angled roof pieces so we could build a shelter for our roof. If I want to put windows in the walls, I can put windows in the walls. I can also rotate the windows. And then finally, I can put floors. So if we want to put floor under the window, you can do that. You can put floor on the ground, fill in the space here. So lots of floors, cool items. If you hold right click too long, if you hold right click for 2 seconds, it actually destroys blocks. So let's go ahead and take this one out here. 1, 2. Okay, and you can see it goes back into our inventory here, and then we can click on it again, and we can place it again. Boom. Let's say if I want to remove the floor underneath, 1, 2. Okay, and I can move the floor over here. Okay, 1, 2. Put this floor right here. And this is what we need to build the basics of a player house, a la Minecraft style. Slightly different, but mostly Minecraft style. All right, you can see a little guide up here, Q and E to rotate. Left click to place them, right click to break. It takes 2 seconds to break. Click on the block to place it down, directions here on the bottom. Okay, hitting escape. All right, let's take a quick look here. Okay, so on the player character, what we do is we'll look here first, and then we'll go into the C++ behind it. Okay, so rotate block, we're using a C++ rotate yaw function here. We're spawning a ghost block first. It gets the ghost block from the C++, sets it as the block type, so we can interact with it later when we put down our permanent block. The ghost block is, we'll look at that a little bit later also, what we use for that. Okay, we get from the enum, we set the crafting item type. We get the player HUD to the reference. If we're set to is building mode, which happens when you press the B button, we go ahead and do a line trace to spawn our initial actor as a ghost block in front of us. And then we set the material to material instance ghost block, which if we look at the material instance for the ghost block is I made a master translucent material and then a child based on that where I set the opacity to 0.5, I set the color to green, and then I apply that to the ghost blocks. That way you can see through it. Okay, there I set collision to no collision, and I set is selected. That means that is the block that is actively selected. That's a blueprint boolean that I created. We set that to yes, it is selected, and we set it to that is the current block, which is tracked inside the C++. To replace it with the permanent, this would be relatively easy to actually change over to C++. I actually helped somebody else do theirs in C++. I just hadn't done it with mine. Okay, picking the block back up using the right mouse or the block break. We get the player controller. We check for what's underneath the cursor. This one's set to trigger after 2 seconds of being held down, which is controlled in the trigger settings for the input actions. Okay, if it's under it, that's true. We break out under mouse cursor to get the hit actor type. We get the class type it is. We get the display name. Then we filter it down to a substring because I only want the first 6 characters. that way I can do a switch on string, and what that does is it returns back the type of item that we had as back to our inventory, calling the change item quantity from the crafting component attached to our character. I wanted to be able to go straight from class back, but I could not find a way to do that. So this is a workaround here to split and string, because you can do switch on string. Let's see, what else is it? Okay, once you have the ghost block, when you left mouse click to place the permanent one, it checks is it a valid and is it current. We get the static mesh of the ghost block. We get the world location and world rotation and the block type, which was set down when we initially did our spawn. We spawn our actor. We change our inventory quantity for that enum type on our crafting component, and then we destroy the ghost block actor. Also very easy to implement in C++. Actually help somebody else implement that in C++. I just hadn't done it for myself. All right. On the character, we have a crafting component now. All it does is it tracks how many items have been crafted. In this case, it's currently set to 0 elements. We'll see in C++ how that gets set up. All right, let's go. Okay, building. I have my base static meshes. I built all of these in Maya myself, and then put them into blueprints to add the materials to them, as well as our builder guide. Started to do some chaos destruction, but hadn't gotten around for breaking the blocks using chaos, but it's being implemented. I think that finishes it for that. Let's go ahead and jump over to C++. For C++, okay, first I did a crafting component. And the crafting component, attach it to the character, set up our initial delegate to update the widgets. Let's see, I set up a T-map with the enum for the crafting item and quantity, and we store those as crafted items inside the T-map. If we want to change the item quantity, we got a function here. If we want to craft an item, we got a function here. If we want to get the amount of items, we got it here. And then we call the delegate on crafting update to call it inside the widgets. Go to the component. Okay, we set up our initial changing the item quantity. We clamp it from 0 or whatever the current value is. That way there is no max value. Whatever the current value is the max value, but it will not go below 0. Let's see, craft items, currently this is not implemented here. For get item amount, all we're doing is just using the ternary operator and returning back either the quantity or 0 if we can't find the item in the T-map. Let's see. Looking at, I have crafting types. This is just my enum here. Very simple. You enum here with the count in the bottom. That way we can do an enum range by count. For the basic building block, I try to keep all the logic for the blocks themselves, including rotations and placements, stuff like that, within the block CPP. I do not believe in putting all that stuff on the character, so we did not put it there. Okay, in here, we got the constructor, the static mesh, rotate, pitch, roll. In this case, we're only doing the yaw rotation. Move to cursor. This is so the block, when your mouse moves in the world, it'll do a trace under the cursor, return that result, and then the moved cursor will keep moving that block to your cursor until you've placed that block down. Okay, let's go look. Okay, we do our basic static mesh on the constructor, set it as root component. We got our rotate here. We can call each of these are U functions, so we call each of these if you want to rotate the pitch and the roll as well. It's available, even though I'm only currently using the yaw. Moved cursor, we get that hit result from trace under the cursor, and then we cast, make sure that it is that the hit result is a hit actor of type basic building block. If it is, then it's going to get that building block's location, and then we'll come down here. We're going to multiply the impact normals of the hit result, that'll give us a x, y, and z value of -1, 0, or +1. Only one of the values will have a value. So if x is 1, y and z will both be zeros. If z is -1, then x and y will be 0. So only one value will be non-zero. Negative means it's the opposite direction. 1 means the positive direction. So we're just basically multiplying 100 in that direction. So we'll get a vector of like 0, 100, 0, or 100, 0, 0. And then we add that to the current location of whatever's hit. So if it was another building block actor, it's only going to add 100 blocks in the direction that we want to of the normal, so it'll only build on one side, always snapping to that side. If it's like a train or something that's not a hit actor, then what we'll do is we'll just get the location, grid snap it to 100, and we'll use a -50 here because the pivot point is in the center of the blocks. This will snap them down to the surface. Okay, so if it was a building block or non-building block, regardless, we set our snap location to the hit result based upon the normals of whatever we hit, in the direction that the normal faces. So there's 6 directions, plus whatever the hit location of whichever kind of object it was. And then we go ahead and set our own actor's location there. And what's going to do is, as you move the cursor, it's going to keep running this trace here to get the moved cursor. Selecting the block here, and then so once it's been placed and we want to select it, we can use that. And then here's the tracing the cursor. Get the player controller, so we can get the first player controller. We get the mouse position, X and Y. We're creating 2 out variables for world location and world direction. We go ahead and deproject our screen position to the world based upon our X, Y coordinate plus our player controller's world location and world direction. And then it takes those out variables, which these 2 are the out variables here, assigns the deprojected values into them, which gives us our end plus the direction times 1000. So it's like if your camera's facing forward, it would be the forward vector. In this case, it's the world direction times 1000. And we set that as the endpoint. Set up our parameters to ignore ourselves. And then we go ahead and do a line trace that it then returns. So we're basically returning the line trace using those parameters. That way, wherever we move the mouse on the screen, the object will follow the mouse. All right, let's see. Anything else we've done to our player? Let's look real quick. Let's see. We have adding and removing our status HUD, but that's more of week 4 stuff. Yep, just a simple shortcut. Instead of just saying add view to viewport, remove to viewport, I made it shorter. That's for our status hub. You know, we got our progressive bars, their text that's overlaying them. We're binding them to the widget. And then we're calling the functions for update health, hunger, and stamina. When we look at the widget, okay, we set our initial percent. And then when the update is called, so yeah, we set it initially at whatever the percent is, and then whenever an update is called, we put the text over the top of it with the health, the max health, to give us the slash in between. The percent is gotten also from the same 2 values. And we do the same thing for the update hunger and the update stamina. And this is all a user widget in C++ that we're just updating in the game. I think that actually covers week 4 requirement as well. Let's see, let's look at our bit bucket. Okay, here is our pushes. So it looks like from, let's see, a dynamic crafting widget. So that was the crafting window that you saw where you can increment, decrement, and hit the craft button. And it adjusts the different supplies on the left side. Let's see, we updated the crafting UI. We added some child widgets. Oh yeah, that's one thing. So the UI, see, widget blueprint crafting child. There we go. So our widget blueprint, this is it. So basically, we just bring in the resources and crafted items, which are actually other widgets. We just bring them in here as widgets, and then we have a scroll box here. See, I don't think there's a whole lot of code in here. Let's see. We update. So for the children, what we're doing is we're getting the information from the data table, that contains your icons, the enum name, the stone, how much stone it requires and how much wood it requires, as well as an index value as it loops through the data table of crafting recipes. And then it dynamically populates with children. Each of those, and each child then receives its information as it's created, and then we add the child to the scroll box. The children themselves, this is just the child right here, so it's the icon, product name, stone, wood, these are static, but the text underneath is dynamic. And then you can increment and decrement the input box in the center, or you can manually type in, and then when you hit craft, it gets the number here. Also, when you increment and decrement, it updates the numbers down here on the left. Looking at the graph real quick for that one. On the construct, get our components. We save our crafting component and our resource component. That's the left and right side. That way we can do updates to them. And then we go ahead and set up our initial text and information that we received from the scroll box parent. It provides the information for updating the text here. And then if you decrement or increment, it updates the information. I made two small macros. This determines if there's enough. So if you try to create it when there's not enough resources, it prints string, not enough resources. Later on, I'll probably make a widget notification text that goes across the top of the screen to send those to update those notifications. But if you do have enough resources, then it go ahead and runs the change quantity function from C++, add to resources from C++ for the resource component, and add to resources, so the stone and the wood from C++. Also check the needed resources again. Macro versus function. Macro is internal to this widget only. If I were to use it outside in other locations, then I'd go ahead and make it functions, but for this one, it just worked because I only need it for this one. So we're just taking the resource component, getting the amount of stone, getting the amount of wood, and we're returning it. And then needed resources. This gets this from the data table. So we can get the stone quantity, the wood quantity, multiply it by the quantity text box, and that goes ahead and outputs the total amount of stone needed. So if it was normally 4 stone, but the quantity was 2, then it would say 8 stone, like that. So those just very simple macros to just keep it a little bit cleaner inside the table here, and because I use it a couple of different places, and also up here I need to use it there as well to update the text windows. Also up here needed, so internally I use it, so it just made sense to make a macro for it. I think that just about covers that. Let's see what other UI changes there were. Oh, player stats. So this is the one that comes from C++. Hence, there's nothing here in the graph because it's all updated in C++. I just made it look fancy here with the text and everything. You have to put an overlay for each of these items to get text on top of a progress bar, because you can't put a text directly on a progress bar as a child. Let's see. Okay, so this right here are different, our wall, floor, roof, and window. It just comes in. We set up our initial binding to the crafting component, and then there's a delegate, so we call it bind to the on crafting updated delegate, which then updates the quantities, and depending upon what type of item is being crafted, it will set the text difference to that item. Let's see if I mixed anything. Key presses, so I'm on play. Okay, so a C opens that, B opens that. You can also press C and go straight to B or straight to C and go back again. Pretty simple on that. What I'm actually planning on doing is I'll add icons for inventory and icon for crafting. That way, if a person's on a mobile device, they can just click on the icon as a button. So the icon is a button icon. To do that, or players can click on it. That way they don't have to memorize the C and the B, but the C and B will still be optional key presses for hotkeys if people don't want to actually click on the icons themselves. That should cover it. All right, thanks.